Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this height using parents array problem of the GFG. So in this problem we are given an array of size n where each array I represents the parent of that particular node I. Like here, if this is the given node, these are the parents node like 0, these are the nodes 0, 1, 2, 3, 4, 5, 6, and these are the parent node -1, 0, 0, 1, 1, 3, 5. Now -1 means it is the root node. It is the root node. I mark it with some other color. It will not visible that clear mass. It is the root node. Okay, it will, so it is the root node. So here 0 is our root node. Okay, you can say 0 is our root node. Now the parents of our node 1 is 0, our node 1. Parents of our node 1 is 0. Parents of our node 2, this is our node 2 node, and this is the parent of that node 2. Parents of 2 is 0. Parents of node 3 is 1. Parents of node 4 is 1. Parents of node 3, node 5 is 3. This is node, this node parents is this 3. Okay, and parents of node 6 is 5. Parents of node 6 is 5. I should use the red color. Parents of node 6 is 5. So this is the tree that will form, and we have to find out the maximum answer, the maximum, the height, the maximum height. So what is the maximum height? This is the maximum height. Okay, which is equal to 5. Which is equal to 5. Okay, so now how we will solve it? We have to solve it, and as you can see here, time complexity is n square. And that can be possible. Okay, so what we are taken, we are making a variable h, initialize it with 0, and for each integer, for each value 0 to less than n. Okay, for I should use from 0 to n, because here it is not specified that ARR 0 will always be the root. It is not specified, as it is written here. There will be a node in the array where ARR is equal to -1, which means this node is the root of binary tree. Means any ARR I, means from 0 to n minus 1, any ARR I will be is equal to -1. Okay, like here this is -1, but it can be last one as well. Okay, which is the root of the array. So for 0 to n, for each node we will check the maximum height of the tree from this particular node, and we will put out h is equal to maximum h comma find, and we are pass out find ar comma I. This is the function over this. Okay, and what we are doing, if we are at the root node, if we are at the root node, then we will return 1. Means it, this root node has the level 1. Okay, you can say like this. Okay, so if you are at the, if we are at, just a minute, I am write the answer. So if we are at this level, if we are at this level, we will return 1. Means this is the initial level. Like suppose we are at 3. We are at 3. Then what we are doing, we are passing in our function arr, means array, and this value 3. Okay, means we are at node 3. Then in 3, in index 3, we are at node 1. We will check if our arr x here x is equal to 3. Here arr 3 is equal to -1. No. Then what we return, 1 plus find arr comma 1 plus a function arr comma the arr x, the parents of that particular node, arr x. ARR x. What is ARR 3? ARR 3 is 1. Okay, so we can write here 1, and this function will call, but it will check ARR 1 is equal to -1, ARR 1 is equal to 0. No, it is not is equal to -1. So it will return 1 plus ARR, and this function ARR comma ARR 1. ARR 1 is 0, so it will return ARR 0. Now function will again call, function will again call, and it will check whether ARR 0 is -1. Yes, it is -1, so it will return 1. Okay, it will return 1. So how will it work? I'm showing you. It will return 1. Okay, so we can say value of this is 1. So this is equal to 2. Or we can write is as like this. So okay, so this is 1 plus 1 is equal to 2. It will return 2 here. So value of this is 2. So it will return 3, and it will return 3 to here. Okay, and 3 will come at this position. So for node this level is 3. So we can check first level, second level, third level. Okay. Similarly, what we are doing, we are passing the node, then we are then we are recursively call its parents. Like from 3, we call 1, from 1, we call 0, and when are at 0, we will check AR 0 is equal to -1, then we will just return 1. Else, why? What we will return? Like suppose we are at, here is a node, we are at here is a again node. Okay, suppose this is a binary tree. Okay, suppose then what will happen for this node X when we are this node? Okay, here is some more binary tree just for example. Then this node will call out to its parents. Suppose here is a node A who is its parents, who is X parents. Then what will it do? It will return 1 for its level, that 1 for my height, plus the height of my parents, plus the height of my ARR A. A is its parents. Okay, height of ARR A. Again it will do, it will return 1 for me plus height of my parents. Suppose 4 is parents. Okay, now height of 4. Now what will 4 return? 4 will return 1 plus height of my parent, that is equal to 1. Now 1 will call out 1 for me plus my parent is 0. My parent is 0. Now when we will call out for 0, it will return call out for 0. For 0 we will return 1 because it is the root node. So here 1 will come. Here 1 will come. 1 plus 1 is equal to 2. So here 2 will come. Here 2 will come. So 2 plus 1 is equal to 3. So here 3 will come. So 3 plus 1 is equal to 4. So here 4 will come. So here 4 will come. So 4 plus 1 is equal to 5. So here that we call ARR of X, ARR X will return, ARR Y will return to us the 5. Okay, it will return us the 5. Oh, and 1 for it's particular. So our answer will be is equal to 6. 5 I am adding 1 and this is 6. 5 we are adding 1 because we are passing that node, and add plus 1 also for that particular node. Okay, so I am submitting it now. So okay, you can see correct output. So guys, you can see all the 200 test cases pass out. Time taken is also very low. Okay, so guys, here what we are doing, we are calling the parents of a node from this particular node. You can use HashMap for decreasing the time complexity, but because their time is already very low and it is given that we have to use, why I did not use HashMap or vector, because here auxiliary space complexity is O1, and for space complexity O1 the loop will be is equal to O n square. For that reason I don't use HashMap. Unless you can use HashMap, then your time complexity will decrease to On. Okay, like once if you calculate for this path, then you have the height of 0, height of 1, height of 3, height of 5, and when you are calling for 6, then you just call its parent, its height is 5, and you will just return 1 plus height of 5. Suppose its height of x. If this has some other node, it will call to it, make call to it, then it will not checking for all the nodes to its root. It will know the height till 6. So it will return height of 6 is 1 plus x. So it will return 1 plus x. Now y 1 plus so take it y is equal to 1 plus x. Y is the height of its parents and 1 for this level. Okay, so this is how we are approaching this problem. You can use HashMap as well, but this is the O(n) square and O1 space complexity solution. So I am telling you the both the solutions. You can use your HashMap or vector solution as well, which will take O(n) square, O(n) time only. It is O(n) square. So guys, I hope you all like it, you all understand it. And if you still have any doubt, then just comment out. I will try my best to explain you, to clear your doubt. And in the meanwhile, you can subscribe my channel, you can like the video, and you can check out my channel for more these type of videos. Thank you for watching this, guys.